All right, settle in. I'm going to tell you the story I just learned. I just spent over 2 hours diving into this one conversation, and honestly, it completely changed how I see everything, including the very act of thinking we're doing right now. This story comes from an Andrew Huberman podcast with Dr. Jennifer Groh, a brilliant neuroscientist. And it's not just about eyes or ears, it's about how our brain builds our entire reality. The story they told unfolds in 6 main parts. Part 1, the biggest question: what is thought? It all started with what seems like a philosophical question. What is thought? Is it just an abstract idea, an invisible spark? Dr. Groh proposed a theory that made me rethink everything. She said, thought is simulation. Try this. I'll say the word cat. What just happened in your head? You didn't just access a data file named cat. I bet for a millisecond, your visual cortex ran a simulation of what a cat looks like. Your auditory cortex might have simulated a meow. Andrew Huberman jumped in immediately, and this detail is perfect. He said, I thought of a gray cat, but mostly I'm smelling kitty litter. Why? Because his sister had cats and he hated the smell. You see? His thought of a cat wasn't a clean data file. It was a multi-sensory experience instantly linked to a powerful memory of smell. His brain simulated the smell. Dr. Groh suggests this might be why we humans are so smart. We have more extra sensory brain tissue than other primates. Not to see better, but to simulate better. Higher thought is just running these complex simulations. Part 2, the driving metaphor. When simulations collide. So if thought is simulation, what happens when we try to run 2 at once? Imagine this scenario. You're driving on the freeway. It's raining. Traffic is heavy. You need to merge right now. You're also having a deep conversation with the person next to you. What's your first move? I bet you turn to them and say, hold on, be quiet for a second. Why? Why does talking, an auditory language simulation, interfere with driving, a visual motor simulation? Dr. Groh's answer: because they are competing for the same processing resources. Your brain is overloaded. You're not just distracted, you're asking your processor to run 2 high-res programs at once. You must shut down one simulation to allocate 100% of your resources to the one keeping you alive. Part 3, the magic of sound and the 0.5 millisecond paradox. Okay, so our brain simulates, but where does it get the data? Let's talk about hearing. This is pure physical magic. How does your brain know a sound is on your right? It uses 2 main clues. 1 is intensity. The sound is louder in your right ear. 2 is timing. The sound hits your right ear before your left. And this is where the story gets wild. How much before? The maximum time delay is only half a millisecond, 0.0005 seconds. This is a huge paradox in neuroscience. A single nerve firing an action potential takes longer than half a millisecond. So how can the brain measure something faster than its own ruler? The answer is spectacular. It doesn't use one neuron. It uses a network. Signals from both ears race into a hub. The brain just sees which neuron they met at, like a coincidence detector. That's just left, right? What about up, down? A sound from the ceiling hits both ears at the same time? The answer is in the weird, specific folds of your outer ear, the pinna. They aren't for decoration. They are a sophisticated audio filter. They create an acoustic fingerprint, a unique notch in the frequencies. Your brain has learned, this pattern means the sound came from above. They even joked about the cauliflower ear that wrestlers get. When the ear's shape is deformed, that physical filter is broken. This means they might actually have trouble telling if a sound is above or below them. Another cool detail: why does your voice sound so weird on a recording? It's because when you speak, you hear your voice in 2 ways. 1, through the air into your ear canal. 2, through bone conduction as your own skull vibrates and sends the signal straight to your inner ear. A recording only captures the air signal, which is why it sounds thinner. Part 4, Dr. Groh's big discovery, the ghost in the machine. This brings us to Dr. Groh's core discovery. She knew the brain combines sight and sound, but she wondered, how early does that combination start? Could it start at the ear itself, They designed an incredible experiment. They placed a super sensitive microphone inside a subject's ear canal. They had the person sit in a completely dark, completely silent room. Then they just asked them to glance their eyes from left to right. And this is the discovery that changes everything. The microphone picked up a sound. The person's own eardrum was moving. It was creating a tiny sound just from the act of looking. It wasn't just moving, it was moving in an organized way. When the eyes glanced left, the two eardrums moved in opposite directions. And, most amazing, the farther you glance your eyes, the stronger the eardrum moves. What does this mean? It's a preparatory signal. Before you even finish looking in a new direction, your brain is already sending a motor command to your ear, physically tuning the eardrum to prepare to hear sounds from the direction you're about to look at. Part 5, the chicken hypnosis anecdote and the locked brain state. So if our brains are this interconnected, can one sense control our entire brain state? The answer is yes. And Huberman told the story of chicken hypnosis. You can apparently hypnotize a chicken. Here's how. You hold it, draw a line on the ground, and put its beak on the line. The chicken will stay frozen for minutes, just staring at the line. Why? It's not hypnosis. It's hyperfocus. A chicken has eyes on the side of its head. To peck a tiny seed, it has to perform an extreme eye convergence move, basically crossing its eyes to focus on a single point. This visual act is so intense that it locks the chicken's entire brain. It gets stuck in that cone of attention. This is a powerful metaphor for how our vision, when locked onto that glowing little line on our phone, can lock our brains, making it impossible to look away. Part 6, 2 philosophies for surviving the modern world. So what do we do? How can we actually get work done? This was my favorite part. The 2 scientists have completely opposite strategies. Strategy 1, Huberman's cave, deep focus. He needs a cave. He goes to his basement, no phone, no internet. He admits the first 15 minutes are excruciating. His brain is screaming for distraction. But after he breaks through that barrier, he enters a state of deep flow for hours. Strategy 2, Groh's intervals. Trust the unconscious. She said, I can't do that. She works like an athlete doing interval training. She will write one difficult academic sentence. Then she intentionally takes a break, maybe scanning the news. Why? She trusts the marination process. She knows that while her conscious mind is distracted, her unconscious mind is still solving the problem. When she returns to her desk, the answer for the next sentence is ready. And finally, their tech solutions. They both struggle with their phones. Finite apps. She avoids the endless scroll. She uses apps that have a clear stopping point. She will do one lesson on Duolingo or one New York Times crossword puzzle. When the app says you're done, it creates a natural exit ramp. Huberman's solution, physical friction. He admits he doesn't have the willpower, so he built a barrier. He has 2 phones. His main phone does not have social media on it. He has an old separate phone just for Instagram and X. The physical effort of having to get up and find that other phone, that friction is enough to break the unconscious habit. And so that's the whole journey. We started by asking, what is thought? It's a simulation. We learned how our ears work. They're faster than our neurons. We discovered our eyes physically move our eardrums. And we ended with 2 life philosophies for how to survive in the modern world. It leaves me with this weird sense of awe that we aren't just living in the world. Our brain, every single second, is actively building it for us.